Cities everywhere are experiencing longer and hotter heat waves due to climate change. MITRE researchers have developed a novel modelling approach to identify high heat stress areas within cities. This microweather model can help city planners, sustainability officers, and policymakers think strategically to better understand and mitigate heat stress today and in the future. Typical atmospheric models measure weather on the kilometre scale, which is not the right resolution to understand heat stress differences at a neighbourhood level. We take a close-up perspective by modelling weather at 3 to 5 metre resolution. On any summer day, conditions can vary greatly from one block to another. Our more vulnerable populations, including lower-income families and the elderly, are disproportionately affected by the heat because they may not have the resources to keep cool. Cities are looking for ways to combat this inequity. MITRE partnered with Aeris LLC to use its high-resolution atmospheric physics model to simulate microscale weather conditions in cities. This rapidly executing model creates digital twins of cities and their climates. By changing the parameters in the model, users can experiment and assess trade-offs, changing things like the size and location of buildings or adding green spaces. Local governments can use this technology to identify heat stress areas in real time so they can take immediate action, such as adding cooling centres and emergency services. They can also use it to look at future scenarios to confirm benefits and unintended consequences of planned development. To date, we have collaborated with New York City, Raleigh, North Carolina, and Miami-Dade, Florida, to test and evaluate the microweather modelling approach. Overall, the model shows where, when, and how denser build-out with less space between buildings can contribute to increased heat indices. Taller buildings that are more spread out can create ventilation corridors that help mitigate heat stress while still supporting urban growth. We can also model the effects of heat mitigation techniques, like adding reflective surfaces and tree canopies. The microweather team continues to enhance the modelling services as they work with more cities and their unique environments, fighting extreme heat with the right information and better planning.